Hello, my dear students. I hope you are doing well. In this lecture video, I'll be discussing about the fundamentals of force. So at this point in time, when you are viewing this lecture video, you are now into the study of forces and how they affect motion. Okay, so that after this, when we're able to understand or have a good grasp of what force is, no, in the physical realm, of course. uh, Hopefully by the next part of your study of physics, you will later understand how force and energy also relate with one another. But at this point, we'll talk more about forces. Okay, so I would like to believe that you have been studying forces since you were in grade school, no? So this time, since you're already in your tertiary education, then we will focus more on the applications of these principles in physics. But before going into the applications, we have to check our conceptual understanding of what force is. Okay, so let me share my white screen with you. Yan. So let's start on the fundamental definition or description of force. We've been taught since grade school that what a force is either a push or a pull. Okay, that is correct. But if we describe it in a more complete way, we'd say here that force is a quantitative description. So please take note of these key phrases. It's not just a push or a pull, okay, but it's actually a quantitative description of the interaction between two bodies, or a body, the interaction between a body and its environment. So quantitative description, it means that it is measurable. Because if a physical reality, again, is not measurable, either directly or indirectly, then physics cannot be studying that. No? That will be studied in other disciplines. So it's a quantitative description. It means that force, therefore, is a physical quantity. Okay? Bear with my writing. So it's a physical quantity. Particularly, it is a vector. Okay, at this point, you already know what a vector is. So of course, you can determine its magnitude, its strength, and it's important also to note the direction where it's going. Now, when we speak of interaction between two bodies, then this is what we mean by the usual description of force, that come it comes in pairs. So, in pairs talaga. Okay? Or in pairs. Okay? It means that force, when we speak of force, when we measure the interaction, it's always happening between two bodies or a body and its environment. Okay? Kaya, we say that we speak of force as being exerted by an object on another object. Okay? And then at the same time, we learn in the law of interaction that the object that receives it will also exert an equal but opposite force on the other. Okay, so we say that these two uh, interaction, okay, the magnitudes are equal, but they are going in opposite direction. So we have, if this force on 1 on 2 goes plus, then the reaction to that is towards minus. Or if this goes minus, this goes towards plus. So you will learn more of this particular, this is very important, no? So we call this the third law of motion by Newton. Yan. You've learned this in your uh, basic ed physics. Yan. We also call this as the law of interaction, of course. Yan. So it means that every time we speak of forces, you immediately know that there's a recipient and there's the one that exerts it. And if these two, this pair of recipient and receiver uh, the interacting bodies are at the same time the recipient and a an exerter of force, no? Kasi nga in pair siya. So that's very important. So when we measure the strength of their interaction, then we of course call it force, no? In the SI unit, of course, it's measured in Newton. Yan yung gagamitin natin always. It's other units of measurement, the smaller scale would be, or the unit, you also have dyne, okay, dyne. And then for British units, you have pounds. Yan. So please take note, okay, of the unit, that kilograms is not a unit of force, okay, because it's a unit of mass. Mass and weight are two different things. So we'll talk more about that later. Yan. So two bodies in environment, okay? So, ayan. And when we speak of interaction, then the interaction can, of course, either be a push or a pull. So, when two objects are interacting, object one, object two, they either push or pull each other. And then, when you measure that, either in dyne, in pound, or in Newton, then you're actually determining force. No? You are determining the quantitative amount of interaction between two objects. Okay, I hope that is clear now. So there are two ways of classifying forces. So one of the most common is we have here the classifying forces according to the four fundamental forces in nature. So you have the strong nuclear force. Okay, that's first fundamental force. So this strong nuclear force keeps the protons and the neutrons together in a nucleus. Okay, you probably learned in your chemistry before that if the two electric charges are of the same polarity, they should be repelling. But in a nucleus, you have their same positively charged protons, of course, but they're not flying and disintegrating. So that is because of the very strong nuclear force that keeps the nucleus of all atoms together. Yan. And then we also have the weak force, which is a short-range force and is responsible uh, in the decay of a neutron into becoming a proton and an electron, and thereby releasing radiation. Okay, and then we also have electromagnetic forces. This naman is responsible in keeping the entire atom together. No? So you have probably learned before that uh, if an electric charge is at the same time moving, then it always emit an electromagnetic radiation, right? So in any atom, you have there the protons, positive protons that are not moving, but you always have these ever moving, restless electrons. So that will that's telling us that all atoms emit electromagnetic radiation. So this electromagnetic force, they keep the atoms together. And then the last fundamental force in the universe is the gravitational force. So if the strong nuclear force keeps the nucleus inside the atom together, okay, and the electromagnetic force keeps the entire atom bind together, then the gravitational force naman, it can bind the uh, systems of stars in the universe. No? So that's the parang infinite yung range ng gravitational force. Okay? So in the scope of our course, Physics for Engineers, we will focus on doon muna tayo sa mechanical part, no? Sa mechanics muna tayo. Physics 2 will cover electromagnetism. So that's for the four fundamental forces. But in the context of our course, we will look into another way of classifying forces. And that would be the contact forces and the non-contact forces. So I will just focus on the most common forces that we will be studying in our course. Okay? Yan. So, in addition to the four fundamental forces of classifying interactions, we have contact and non-contact here. So, for contact forces, from the name itself, it's just telling us of these are the kinds of forces which happens only when the interacting bodies are really touching each other. That's why it's called contact forces. So, ayan. Number one that we will be studying in the common systems in our course would be the normal force. Okay? I would like to believe that these forces that we are studying here now are not new to you. No? You've had this when you were in STEM strand, when you were in your senior high school, okay? Or even in junior high, kahit anong STEM strand ka. So let's just put this in a large way. Ayan. So mathematically, you probably learned that this kind of contact force, normal force, is called as such because of the mathematical meaning of the word normal. Okay, so in math, normal means perpendicular. Okay, or making a 90-degree angle. Okay, by the way, let's agree for uniformity that we will label normal force. So you have F for the generic symbol for force as a vector. Don't forget the arrow there. And then we have a subscript, a small letter N. So I hope you know how to write subscripts, no? It should be written much smaller than the main label. Yan, dito siya sa baba kasi sub. Okay. So, 90 degrees. In other words, if the system that you are studying, let's say for example ito, a pile of cement sacks. This is our system resting on a platform here. So if the weight of the system is being supported by another platform underneath it, then that platform, ito, okay, exerts a 90-degree angle. Ayan. So it always goes upward, no? Pushing force itong si normal force. So without the platform here, then the entire stack will fall down. Ayan. So pag nag show na tayo ng free body diagram later, we only show the resultant, no? The total of all the small normal forces here in the all small areas underneath the sack of cement here. Ayan. May mga maliliit yan na normal forces. So, hindi na natin ipapakita yan sa free body diagram, but we will just represent the resultant. Kaya isang arrow lang ilalagay natin. Okay? So it's always 90 degrees with the platform or the surface that is exerting it. Yan siya, normal force, arrowhead, and then label. Ito naman, if the system were a box resting on a ramp at angle theta, then this is the part of the ramp here that supports the weight of our box. So immediately you know that there's a resultant force here of all the small normal forces there. Okay? Yeah, it should be straight. And then label F sub n. And then you just tell the world that, hey, this is 90 degrees with the ramp by showing the symbol here for right angle. Okay? And then another example here, if we have a man here that is leaning on a wall, standing on the floor, then there are two kinds of normal force here because there are two parts of the environment of the man. Ang man natin, ang system here. Okay? You have to take note kung ano yung pinag-aaralan mo, yung ina-analyze mo, and we call it a system. In this case, it's the man here. So at the bottom part of the body of the man, it's in contact with the floor. Kaya this portion of the floor exerts an upward normal force. Ayan. So we can call it F sub n by the floor. Okay? And then, if the man is pushing on the wall, then the reaction to that would be the wall pushes on the man. And that pushing force of the wall on the man is the normal force. So that ito siya, we can label this as F normal and then wall. Tapos, ayan na siya, 90 degrees yan, 90 degrees yan. Okay? Ayan, so that's the normal force. So when we analyze systems later, immediately you determine whether or not the system receives a pushing force from any surface. The normal, so that normal force is present. Okay? If a certain system is just suspended on air, edi wala siyang normal force. Okay, na natatanggap. Yan. Okay. Now, another common force that we will be encountering in our study would be tension or tensile force. So, symbol natin, let's agree, capital F with subscript capital T. So, we will apply Newton's laws later in understanding more of the stability of structures like this. Okay? So, si tension naman, class, is an interaction of any elastic material that is connected to another object. So in this case, the interacting objects here, ang pair natin dito sa bridge, for example, you have the cables, and then of course the bridge itself. Ito. So if I'll just represent the bridge as if it's a box, and then may cable dito. Okay? Ayan. So immediately, the cable here is a medium where a pulling force actually is transmitted. Okay? So in this case, there's tension here in this cable because it somehow supports the weight of this bridge. Okay? So tension, therefore, in this case is the interaction between the cable and whatever object is connected to it. Okay? So again, if you have an object and then there is cable, for example, tension is just the interaction between the cable and that object there. So it's always a pulling force. Okay? Pulling force siya always. Kaya whatever is the orientation of the cable, yun din ang tension, of course. Kasi hindi naman pwedeng lalabas sa lubid yung interaction. It's along the cable here where actually the force that is actually happening at this point of connection between the cable and the object here gets transmitted all throughout the cable. Yan. So tension here is the force of the cable on box. Ayan. So, klaro na yan ha, na pag may rope, cable, string, for example, it's the interaction between that elastic material and the object na pinagkabitan sa kanya. It's the rope will just serve as a medium where force is transmitted because the rope itself cannot exert force. There has to be another source of force, di ba? So say for example, kung meron kang box and then you have a cable or a rope, hindi namang pwede na the cable will pull the box itself. So there has to be another source. So let's say ikaw, ipupull mo siya, and yung pulling force mo gets transmitted through the rope until of course it somehow it's as if you are pulling directly on the box. So in this case, hindi ka na natin papansinin dito, but we will just focus on the tension on the cable when you show the FBD of the box later. Okay? Ayan, I don't want to make this video very long. Baka I need to stop in one point and make this as part 1. Okay, so this is just an example of a diagram of a suspension bridge where the cable here undergoes tension kasi tension is always a pulling force class, ha? Pulling force yan. Okay. And then the opposite to the pulling force, tension is of course the compressive force. So it's being experienced by the tower here. So the two towers that support the entire bridge undergoes compressive forces, but the cables undergo tension. Yan. Okay? Bottom line, class, kung merong system na may mga lubid, rope, whatever, immediately may tension dyan. Okay? Ayan. And then, kung ano yung orientation ng lubid, edi the tension will also just be in that direction. But it's always pulling. It's never pushing. You just remember, there's no rope that can push, let's say, a box na pinagtalian sa kanya. Okay? Makes sense, of course. Yan. And then the last one, under contact forces, okay, is frictional force or simply friction. So our symbol is a cursive lowercase of letter F, and then we can just put arrow there. Later, we'll be studying three kinds of friction. So we have static friction. So may subscript S ka dyan. Kinetic friction, subscript K, and probably, I hope we can reach until rolling friction. Okay? Basta kay small letter F tayo for friction. So, friction is, of course, a resistive force. Kontrabida, hindi naman. Resistive siya. So, in other words, if there's any attempt to, let's say, start the motion of an object that's at rest, kung saan papunta yung attempt na external force na yon, si friction ko kontrahin niya yon, specifically si static friction. Or if the object is already sliding, say for example, let's raise this up. So, kung sliding, for example, na siya, yan. So, ito, hindi pa siya gumagalaw, pero meron ng force that is going in this direction, then static friction is responsible there. By the way, I have a different separate lecture video which just focuses on friction, static, and kinetic. So, I will not dwell so much here on this video about friction. And then once it's sliding, then the responsible resistive force is kinetic. Once an object is rolling, then the responsible is rolling friction. Okay? Basta kay it's resistive force. Kung saan papunta yung ina-apply na force or attempt in motion or motion itself, friction goes 180 degrees opposite. Okay? And then we also have friction between a solid object that is moving within a fluid. So when we speak of fluid, it can either be, so we call this friction as fluid resistance. So when we speak of fluid, it can either be a liquid or it can also be a gas. So I hope we can reach until fluid mechanics. We'll talk more about fluid resistance. Okay, so in this case, you see here a car that is being tested for its aerodynamics efficiency, no? Yung air drag coefficient. Depende sa, ayan, ano yan? May background ako na helicopter. Helicopter ba yun? Ayan. Okay, so that's another kind of friction resistive force. Okay? How many minutes na ba ang video na ito? Okay, I'm almost done, class. Now let's go to the non-contact forces. These cannot be covered by Physics 1, but let's just take a look at them. Okay? So for an example, ito, si non-contact force na gravitational force, ito yung sinasabi nating always present, never absent na force, no? Pag nag-a-analyze tayo ng mga system. Okay, as long as the system is on Earth, for example. So we have here gravitational force. Symbol natin is, of course, the symbol of force with G for gravitation. Okay. So when we speak of gravitational force, we focus on ang interacting pairs nito would be the Earth and the body or the mass, for example. So if we speak of, let's say, if the gravitational force, let's say, for example, of this person here, okay, we are talking about, let's say, gravitational force on boy. Ito, on the boy. then this would be the force of interaction exerted by the earth and then received by the boy. Okay? Ayan. So that's what we mean by the interaction. Force as an interaction. Okay? And then you probably know that gravitational force, the strength of this, okay, magnitude, you have the mass of that body in kilograms times acceleration due to gravity, which is 9.8 ang gagamitin natin, meters per square second. And then we can also call this the gravitational force received by any object, okay, because of the uh, Earth, its interaction with Earth, it's also equivalent to the weight, okay, to the weight of the person. So weight, we can consider it as a force. Kaya nga sabi natin kanina, ang unit ng ng mass na kilograms should never be used as a unit for weight because weight can be considered as a force. It's the equivalent to the interaction of an object with Earth. Whereas mass is a scalar quantity, it's just the amount of matter in an object. Okay? Take note of that. So, in other words, in a system, for example, let's say a very simple system, box on a floor, for example, then immediately, since you know that the box here has mass, and then it's on Earth, then the Earth will always pull it down. That's the gravitational force of Earth. And the gravitational force of Earth on that box is just equivalent to its weight. Okay? So, naka-Newton yan. But in Newton's universal law of gravitation, it's not just Earth that has the ability to exert gravitational force on any object on top of it, but it's actually universal, meaning any object that has mass will innately attract another particle with mass also. So, ayan, I can hear Dada's voice. So, where am I? Yan. Kaya, in Newton's law of universal gravitation, you remember that it's not just Earth that can exert gravitational force, but any particle that has mass. Okay? So kaya sa interaction ng weight, kung ikaw ito, you can be mass 1, and then the Earth here, this is mass 2, and then the separation between you and the center of the Earth, that would be the distance between you. It's just approximately equal to the radius of the Earth. Okay? And using gravitation, universal law of gravitation, it's telling us that the magnitude of the force of attraction between any two masses is equivalent to the product of the two masses times this gravitational constant g, and then divided by the square of the distance between them. Okay? What I'm just trying to say here is that gravitation, okay, is universal. So this is true for any particle that has a mass. Whether it's as small as an electron or subatomic particle, may mass pa rin yan. Or galaxies na tremendously high yung mass. So regardless or in between, there's always this attraction. Okay? See, gravity is always a pulling force. It's an attraction. It's never repulsive or pushing. Okay? Kaya ang point natin dito sa sa study natin ng mechanics, the only force that can never be absent is the gravitational force. Kasi nasa Earth siya, tapos may mass siya. Okay? Unless na lang sinabi na massless, no? Say for example, a massless rope. So when we speak of massless rope, it doesn't mean that it has no matter in it. It's just that its mass is very much less compared to the masses of the other parts of the system. So may mass, may weight pa rin yan. Okay? Please bear with me. I'm down to my last two. Ayan. So we have another non-contact force, the magnetic force. Symbol is F sub B, FB. So B here is a symbol for magnetic field. Ayan. So si magnetic force, the two magnets, opposite poles for example, they do not need to be in contact, but their interaction can exist, of course. So this is a picture of a very simple part of a generator, no? Meron kang coil dito, ayan. So when the coil rotates, okay, it changes the magnetic field through the coil here. It generates current. So magiging magnetic itong coil na ito, and a magnet will only interact with another magnet. Okay? So I think uh, I will not discuss more of this as of now. Okay? Yan. So yan si magnetic force exists. It's an interaction between two magnetic materials or particles. Yan. And then related na din dito si electrostatic and electric forces. So si electrostatic force, this is the force that exist between two electric charges. So if you have charge 1 and then another charge 2 separated by a certain distance, then there's this electrostatic force between them. Yan, may F electric yan. Okay? If the two charges are not moving, then we're talking about electrostatic force, the interaction between these two. But when these two charges are already in motion, they become the charges in motion is already called electrical, no? Electrical forces na. Ayan. And then by nature, when this charge move, they become magnetic. So electromagnetic ulit. Okay, they are very much interrelated. Yan. So these happen at non-contact. No, they don't need any contact here. Okay. So I really guess I have to stop at this point. I hope this has been helpful. No, in addition to our PowerPoint and other videos. Okay, I'll have to stop here and then stay well until then.